Our next team, Western Sustainers, is ready to present their solution, an agricultural system that exists symbiotically with the surrounding community. Presenting for Western Sustainers is Max Hornick, studying public relations at Western Michigan University's College of Arts and Sciences. And her teammates are Clara Givens, studying biomedical sciences at Western Michigan University's College of Arts and Sciences. Elijah Lowry, studying geography at Western Michigan University's College of Arts and Sciences. Kelsey Pitchell, studying mechanical engineering at Western Michigan University's College of Engineering. And Ramon Roberts Peraza, studying civil engineering at Western Michigan University's College of Engineering. Max. Where's Max? Show us what you got.
All right. Is this on? Oh, okay. Sorry about that. All right. So I'm Max Hornick with Western Sustainers, and I'm here to tell you how local loop farms can help propel us into a circular economy. Right now, we live in a linear food-to-waste economy. This results in a variety of wicked problems, including misuse of land, water, and wildlife resources. And frequently, food is grown far away from where it's to be consumed, shipped around the globe for processing, and shipped back to the consumer. And this really creates a lot of fossil fuel usage, which contributes to climate change. In designing our system, we use the framework of a circular economy to loop nutrient, financial, and informational resources in ways that will continually serve people and the planet. Our design goals in creating this agriculture system were to increase access to fresh, local, and sustainably grown produce, especially for people with low incomes, to emulate natural systems in ways that reduce the amount of waste we generate, to minimize energy use through the use of appropriate technologies, to create resilient agriculture by using a diversity of species, and to empower communities and really create a connection between people and their food. Our solution uses multiple organisms so that biodiversity really helps us divert any waste streams and reuse that waste. We've created a 2-acre module that's customizable and can be scaled by adding more modules on. And we manage waste streams and hope to partner with large institutions that generate a lot of food waste, such as hospitals. So this is our system. It has 3 major components, the first of which is the aquaponics system. And as you can see, we have several ponds for our tilapia to live in. We chose tilapia because they are in the top 5 most consumed fish on the planet. And their wastewater is filtered and sent through the hydroponic grow beds, where we have our plants floating in rafts, and their roots hang down in the water, absorbing all the nutrients from that fish waste. And they simultaneously clean that water before it's returned to the fish. So this really helps us use our water very efficiently. Another major component of the system is the black soldier fly larvae, or BSFL, composting system. And in this system, we take food waste and potentially yard waste from the community, put it in there. These black soldier fly larvae are the offspring of black soldier flies, which are a small non-pest insect, not a disease vector that's native to North America. And the resulting compost is a very rich fertilizer, while the soldier flies themselves are then processed into feed for our fish. So we're producing a sustainable fish feed on site. We also grow spirulina algae and marbled crayfish, which will also be processed into the feed. And then the feed that we generate can also potentially be used to feed animals or livestock in the community. And the other major component of our system is the hot compost water heater system. And this is really a really exciting part for me. It takes animal manure, yard waste, and really any organic matter, and uses an aerobic composting process to digest that matter very quickly. And the composting process actually generates temperatures of up to 170 degrees Fahrenheit in there, and that heat is then recaptured in a heat recovery system. It's generated mostly in the form of superheated water vapor and air, and we recapture that heat and use it to heat our water for the fish to keep it at the optimal temperature for tilapia growth. So that was one way we helped minimize our energy use. So in this system, our nutrient flow is, definitely follows that circular model. We take animal manure from farms, yard waste and food waste from the community, put it through our system, and out of that, we give back to the community this nice, fresh, healthy produce, fish, and animal feeds and fertilizers from both forms of composting. Our financial flow also follows the circular model. The community invests in the local loop farm by purchasing our product produce, compost, fish, animal feed, and in fees for waste removal services. While the local loop farm invests in the community through the salaries and wages that they give to the workers, and through charitable contributions to organizations such as food pantries. Additionally, our information flow is a very strong point in our circular model. The local loop farm would provide open source research, which would propel not only community information and education, but also the larger aquaculture and agriculture industry. Some new information that may help propel us into that circular economy. Additionally, hands-on experience, such as field trips for high schoolers or potentially internships, institutional collaborations, and consulting services. And the community provides that feedback, that customer feedback, identifies any needs in the community, any food preferences, and manages demand. In terms of feasibility, technologically, all of the system components are proven. Really the innovative thing we did is draw all of these different elements together and put them into an integrated system. The building materials for this are readily available, such as 55-gallon drums. A lot of things are shipped in those. And the system is pretty easy to assemble with minor tool usage. Additionally, financially, this is a pretty feasible system. The building materials that we chose are very low cost, and the operational maintenance remains at a low cost because we use solar panels and we use that heat recovery to heat our water. There's also the existing community need for responsible waste disposal. Most communities are just putting their food waste into a landfill, and that's not very effective. And our holistic business model really promotes that community investment in the organization. There are some barriers that we face in starting this type of business, but we're really working on those. 4 of our teammates work at the Office for Sustainability at Western Michigan, and we're doing research to address these barriers. Our work so far, my teammate Ramon and I work on aquaponics at the Office for Sustainability. Currently, we're conducting research to compare 3 of the main types of hydroponic growth systems. We've also received advice from Josh Schultz, who has worked extensively with aquaponics in the Bahamas. And we have received grant funding to do some research this summer to assess the feasibility and potential for bioaccumulation in this type of feed that we have proposed. Our teammates Eli and Kelsey have been working at the Office for Sustainability, and they designed a compost heat recovery system to heat a greenhouse. And they received a grant for that as well, and they're working on that. And Eli had recently attended a workshop in Oxford, Michigan, where he helped install a radiant floor heating system that's also powered by hot composting. So we're working on that. Additionally, we've sought advice about the black soldier fly larvae from other advisors and researchers at the Office for Sustainability. And the Office for Sustainability is actually currently working on a food waste processing study with black soldier fly larvae. So the overall impact of our system is really that we promote this community investment. We provide people with resources they might not otherwise have access to, and we continually cycle goods and services throughout the community. So I hope you all enjoyed my presentation, and so thank you from Western Sustainers, and I hope you'll help us take local loop farms from farm to plate to farm.